All right, so we are doing transformation of functions. Transformation of functions. This is going to be graphical at first, and then we're going to do the other version. All right, so the functional notation looks like this. Reminder, what is functional notation? That means this is not f times x. This is f is the function name, and x is the input. Now this plus d out here is the transformation. So if you add d and it's outside of the function, right? So f of x is the function plus d. This is considered outside of the function. We have what's called a vertical shift. Wow, I'll put shift. It's shift. Vertical shift up d units. That means it's going to go up d units. So if d is 5, it goes up 5 units. So what that means is if I have a graph that looks like this, and I have a shift of up of 2, I'm going to take that everything here, copy it, but move it up 2 units. It just moves up 2 units. You see examples of that later. Look what you started. She went one step further. Alright, so if it's a minus d, it's going to be a vertical shift down. It'll be a vertical shift down.
I think I've done this before.
Good. This is definitely something that can be covered in geometry and algebra 1.
Yes.
This is so it's like a review lesson. There may be some words that are new, huh?
Mr. John Hostetler taught us this.
How is number 2 up if it's an
You said down and then you wrote up.
What?
It says down.
Oh, okay. Yeah.
I got distracted. I'm sorry. I can smell feet.
Oh, dang. You're right. It's Lily.
It's Lily.
He keeps talking like
It's Bailey.
You got him hanging out on the table. I don't know why someone wants to reach out and grab him.
Okay, keep your hands to yourself. All right. Okay. Now, if I have something inside, this is inside. This is f of x plus c. It's inside. It's going to be a horizontal shift. And it's the opposite direction that you might think. So plus c is going to be to the left. So this is a horizontal shift. To the left, c units. That looks like kunits, but it's c units. Let's put a dash in there. I should have put more space in there. Alright, so it's horizontal shift, left, c units. So if fx plus c is left, what would fx minus c be? Right. So it'll be a horizontal shift. To the right, c units.
Good.
Ready?
Wait, Mr. Spencer.
Yeah.
It's to the right. How is the positive?
Huh?
How is the positive to the right? This is the positive on exactly. Or, yeah.
Because what you're changing is what are the x values that makes it equal to that. So if I have x plus 2 and the original value was 0, then it had to be negative 2 to be equivalent to what it was originally. So that's why it's the opposite of what you think. I didn't understand that answer at all. Well, that one's a difficult, it's a pretty weird abstract. All right, let's look at negative of f of x. Okay, negative of f of x. So whenever it's outside the function, it affects the y value. That's why it's vertical. This is going to be a reflection across the x-axis. So this is a reflection across the x-axis. Reflect across x-axis. So this is a vertical change. If I reflect across the x-axis, that's a vertical change. What do you think this one's going to be? Reflect across y-axis, and that's a horizontal change. Reflect across
Alright.
the y-axis. That's a horizontal change because you're reflecting horizontally. Okay, so this last part has 2 blanks for it. But there really should be 3 blanks because I'm going to give you 2 ways that some textbooks write it, and then I'm going to give you a 3rd way that I prefer to say. Okay? So here, A. So A is multiplying f of x. Okay? And I'm going to put it in absolute value signs. If absolute value of A is bigger than 1, so that means A can be -2, so it's 2. A could be 3, so 3 is bigger than 1. -2, absolute value -2 is +2, 2 is bigger than 1. So basically not fractions, or not small fractions. Okay? So A is greater than 1. This is called a vertical stretch. It's a stretch. It's a vertical stretch. Okay. If the absolute value is less than 1, so it's like a 1/2 or 2/3, okay, but not 0. Okay, it's not 0. Although that would make it true, so it's got to be basically greater than 0. But usually we don't talk about it. If it's 0, that wipes out the function, so that doesn't even make sense. All right, so we call that a vertical. What's the opposite of stretch?
Shrink.
Shrink? What else?
Ooh.
We need a fancier word than shrink.
Get smaller.
Get
Decrease.
smaller.
Decrease.
It's called a compression. But if you put shrink on a test, I'll take it. Okay, it's a vertical shrink. All right. What I prefer to say is it is a dilation of factor A. This is what I like to say, dilation of factor A. I think this is a better choice. You don't have to worry about bigger than 1, less than 1, positive, negative. You just say dilation of factor A. If A is -2, you say dilation of factor -2. If A is -1/2, you say dilation factor of -1/2.
Wait, we only say dilation of factor A for the wait. What?
When there's a number in front of f of x.
So-
When there is a number in front of f of x. Okay? So why am I telling you both of these? Well, this is going to come up on a multiple choice test later. Not one of mine.
What do you mean not when you're?
Like, someone else is going to make up that test.
Wait, you're not making? Is
It depends. Sometimes the county makes tests for us to take.
Is it good?
Is it
Miss
good?
Russell makes. Oh wait, does Miss Russell make the test for this?
She makes the Schoology ones. I make the other ones. Right? Or this. This is what I like, but you should be familiar with both of those. Okay? You should be familiar with both of those. Your pre-cal teacher next year talks about this thing. Vertical stretch, vertical compression. They also talk about horizontal stretch and horizontal compression. I'm not even going there. We'll let pre-cal handle that part. All right. I personally just like this, dilation. Did you guys use dilation in geometry?
Oh yeah.
Yeah. See, dilation is a better choice. Okay, so let's do some examples. We're going to do 4 examples today. All right, here we go. Now, the best way to go about this is just choosing some points and labeling them. Let's call this A, B, C, and D. So we label those A, B, C, and D. All right. Now what we're going to do, so this one, so this is example A, f of x minus 4, what is that supposed to do?
Horizontal shift right, C units.
So that's horizontal shift right, 4 units. Okay? And the best way to do that is you take the coordinates of the 4 points I labeled, right? I labeled 4 points. I'm going to take the coordinates of A. What's the coordinate of A?
-6, -2.
-6, -2, right? So there's -6, there's -2, okay? -6, -2, right? Now, so -6 is the x value, horizontal is the x value. And if I'm going to go 4 to the right, I'm going to do -6 plus 4, so it'd be -2.
What?
Okay? I take the -6, and if I move to the right, I add 4. What's -6 plus 4? -2. I do not change the y value. So I'm going to have the coordinates at -2, -2. And I'm going to call that A, and I'm going to write an apostrophe next to that. And in math, we call that A prime. What was that look for? Okay.
You're so rude, Ashley.
That wasn't rude. I was concerned there was confusion. Alright. So we move the 4 to the right. Now, let's go B. What's the coordinates of B? -3, comma 3. So only the -3 gets affected because that's the x coordinate. So you're going to add 4. What's -3 plus 4? What's -3 plus 4? 1. So it's going to be 1, 3. And that's B prime. So I added 4 to the x value.
Why do we call them A prime B?
What do you want to call it?
Like I'm just asking, why do we mark it this? Why can't we put A and B?
You can. This is force a habit of math teacher. Okay, so where does this force a habit come from? It used to be we used to graph it on the same paper or the same graph. So if you had 2 A's on the paper, that would be confusing. But you're welcome to just write A and B. I will not mark it wrong or anything like that. C. C, the coordinate is -1, 0. Okay, C coordinate is -1, 0. So if I add 4 to -1, what do I get? 3. So it's going to be 3, 0. And that's C prime. I just like just saying the word prime.
Me too. Sounds fun.
Yeah, it sounds like, you know, some kind of modern
Everybody playing baseball now?
Sweet potato.
It's just why
potato.
Mr. Schweitzer, who teaches pre-cal?
Ms. Tepke, Ms. Lambert, Ms. Russell.
Oh no.
I thought Miss Russell was retiring.
She is nowhere near retiring.
How old are you?
Watch. What happened?
Younger than me.
For real?
Yeah.
I've heard Miss Russell used to be in school.
I am eligible for retiring. I'm 54.
Looking like 20.
Because I don't have enough money to retire.
Looking like he's 25.
I have ants. Can you guys see ants on my table when it goes across?
Oh, I see one right there.
Right next to the FX minus 4.
Where?
Right next to the A, FX minus 4.
Right there?
Yeah.
Oh, that one's dead.
It's still moving.
Oh my god, it's moving!
Yes, it's still moving.
It's still moving.
Should I put it out of its misery?
Yes.
It's on camera.
That was so sad.
We got that on video.
He left his good.
I left his guts? He had no guts. There's...
Okay, we can zoom in.
No, I'm not zooming in on guts. Okay. Sorry, folks at home. Alright. Alright, D. D, let's do D. So the coordinates of D are 2, 2. Okay? So you're adding 4 to the x value. So that becomes 6, 2. So you do 6, 2. And that's D prime. And then, where is my panda? Alright. I have a new ruler. It's a panda ruler. Alright. There's A, B, and then connect to C. And connect
Do you love it?
I like it. I'm not emotionally attached to it.
I am.
Are you gonna start a collection?
Oh, that's a great idea.
I'll bring in my Smokey the Bear ruler.
Oh, that'll be the next extra credit. You have to bring in a unique ruler.
Really?
No. All right, ready for the next example? F of negative x. F of negative x. So what does that do? Do you remember? Reflect across the y-axis. Reflect across the y-axis. So let's see what that looks like in terms of this function. Okay, so looking at A, what's the coordinates of A? Remember, it was -6, -2. So when I reflect across the y-axis, you change the sign of the x-coordinate. You change the sign of the x-coordinate. So -6, -2 becomes +6, -2. So we're going to 6, -2. A goes to 6, -2. So there's A. So it went from the left side to the right side. So A prime. And then B. Let's do B. Right? So B is currently -3, 3. -3, 3. All right. Now we're going to go across the y-axis, so that becomes +3, 3.
Reflects across the
Y-axis.
axis.
So
let's put B there.
because B was on the left side of the y-axis, now it's on the right side of the y-axis.
So it would be +3, 3.
Yeah. And then C is at -1, 0, so where does it go? Positive one. There you go. All right. Now D has +2, +2, so where does that go? -2, +2, right? Only the X sign changes. All right, let's connect. I can't see. Okay, we got 2 more examples. Ready? Ready? All right. Why do you keep asking her that? She says yes every time.
You never know when the popcorn's going to change taste.
You can't share that.
I'm not sharing it.
No, anybody. Because sharing becomes a problem. Sharing food in class develops a party atmosphere. And we don't want a party atmosphere.
So what do I say? Cozy atmosphere.
Say what?
Cozy atmosphere.
Cozy's okay. Party's not.
As long as we're working.
See, party atmosphere, then people stop working.
Do you have coffee today?
Do you cherry that?
I did not. Oh wait, I did.
You did?
Yeah, I got one of those iced coffee things.
Where from?
I got one of those like frappuccino. Those, you know, those bottled coffee.
Oh, yeah. From the gas station?
No, from the grocery store. All right, here we go. Yes, I have strange conversations in my classroom. All right. So we are now looking at C. This is on the back. C. Oh wow. This is all right. So this one, what kind of transformation is this? Down 2. We're doing a vertical shift down 2. So you're going to take A, and now you're going to change the Y values. So it's going to go from -2 to -4. So the coordinates are -6, -4. So -6, -4. Yes.
What coordinate are we changing?
We're changing the -6, -2, which is A, to -6, -4.
I know, but like, do we change the Y of the X?
We're changing the Y. So when it's a vertical change, it's a change in the y.
Yes, sir.
Alright, and where is b at? B is currently at negative 3, 3. So if I go down to, where does it end up?
-3, -5.
Negative 3, 1. So the x value is negative 3, the y value is 1. Right? Because the y value was positive 3. Subtract 2, it becomes positive 1.
C.
Alright, ready for C. So C has the coordinates negative 1, 0. So that becomes negative 1, what? Negative 1, negative 2. So that's C. And finally, D is currently 2, 2. It becomes 2, 0. Now we connect.
The panda. Why does it look so tiny?
Say what?
Why does it look so tiny?
It is tiny. You expect a big panda?
Yeah, I saw her there. She had.
Yes, I did.
Hello, my name is Pink. Pink panda. Alright. Ready for the last example? I can't read it. I believe I'm recording this. Alright, ready for D. This one is interesting. Alright, so now we have a number in front of f of x. What do we do with that number?
The last one.
This is a vertical stretch. Okay, so that means we're going to multiply the y values. You multiply the y values. We multiply the y values. So here, so A is at negative 6, negative 2. You're going to take the negative 2 and multiply by 3. So that becomes negative 6, negative 6. Multiply the y value. So the negative 6, negative 6 is way down here. Right, so A prime is way down there. Alright, B. B is at negative 3, positive 3, and you're going to multiply the y value. The y value is 3, so it's going to be negative 3, 9. Right, 3 times 3 is 9. So the x value doesn't change, it's only the y value that changes.
Is it good?
You multiply the y value by 3.
You like A1 steak sauce?
I prefer Heinz 57. Maybe it's because it's sweeter. No, the Heinz 57. It's sweeter than A1. A1's tangy. Alright. What's the coordinates of C? Negative 1, 0. So you multiply 0 by 3 and you get 0. So that one doesn't change. Okay, so C stays where it is, because 0 times 3 is still 0. And then D is currently 2, 2. It becomes 2 what?
6.
2, 6. You multiply by 3. So 2, 6. And we connect.
Wait, my bad, yeah.
You bag it.
When did it become that my bad is the same as I'm sorry?
It's always been that.
First time a person messed up.
Because it transferred to Japanese. Like that whole my bad means bad is bad, right? So in bad, Japanese is warui. But they also say warui to mean apology, to like an apology. How does that translate to a different language?
That's slang, social media.
Alright, that's the last example. I'm giving you class time to work on it. And I want to see you working with understanding, not just filling up papers with answers to get it done. Right?